Is what we see in the universe really real? Imagine flying through space in a light-speed spacecraft. You'd see the stunning Milky Way and the Andromeda Galaxy 2.3 million light-years away. But apart from that, space seems vast, still, and empty. But that's just an illusion. According to Einstein's theory of relativity, the universe is not a static stage. It's a four-dimensional structure woven from space and time, a giant invisible web surrounding us all. Without gravity, a ball thrown in space would move in a straight line forever. But this space-time web is constantly being distorted because any object with mass bends the space around it. The Andromeda Galaxy, for example, is warping the space-time around it as it slowly drifts toward us. In about 4 billion years, it will merge with the Milky Way to form a giant elliptical galaxy. While Andromeda is approaching, most galaxies in the universe are moving away because of the mysterious force of dark energy. The universe is expanding faster than the speed of light. Even galaxies that appear stationary are actually drifting away from us, and their light gets stretched into redshift. Back in the solar system, the sun's massive gravity also bends space-time, pulling everything toward its center. This keeps Earth in orbit, even as it tries to drift away. Earth itself bends the space-time around it, especially near the surface. That's why rockets need such high speed to escape. Place a few apples near Earth, and they'll fall inward and cluster together. That's tidal gravity in action. Tides on Earth, caused by the moon's pull and Earth's rotation distorting space-time slightly. Even a tossed apple's path is curved because of Earth's twisted space-time grid. Dig deep into Earth, and space-time is still pushing everything toward the center. Earth doesn't collapse inward because of pressure from its hot core, keeping things balanced. The planet doesn't grow in size because gravity compresses space-time around it. That's Einstein's curved space-time at work. Now imagine the sun's future. In 5 billion years, it will run out of fuel and collapse into a white dwarf. But if a star is massive enough, its death is explosive, a supernova. Its core may collapse into a neutron star, warping space-time and bending light itself. If even more massive, the core becomes a black hole. A black hole pulls on space-time with the speed of light, forming a growing bubble of energy. When expansion meets contraction, the bubble stabilizes. That's the birth of a black hole. Its edges rotate at insane speeds, creating a whirlpool that even light can't escape, the event horizon. Once inside, everything moves toward a central singularity where space-time bends infinitely. Some theories suggest it connects to a white hole, or even a parallel universe. But the truth is, we have no idea what really happens inside. There, all paths point inward. Even time flows toward the singularity. What you see is not the real universe. It's a warped, dynamic illusion, shaped by gravity, energy, and space-time itself. If this blew your mind, don't forget to like, subscribe, and join us in the next journey across the cosmos. About 13.7 billion years ago, a singularity exploded, giving birth to time and space. As space expanded, around 4.6 billion years ago, our solar system formed, and Earth came into existence. After billions of years of dramatic change, Earth nurtured its first primitive life. Time kept moving forward. Until today, we humans stand at the peak of Earth's civilization and intelligence. We've always believed that with advancing technology, one day we'd unlock the ultimate secrets of the universe. But the harsh truth is, even leaving our own galaxy is incredibly difficult. Since the dawn of civilization, countless people and scientists have tried to observe the universe, to unveil its mysteries. In modern times, two great scientists, Newton and Einstein, finally formulated the fundamental laws of the cosmos. In the early 20th century, Einstein introduced relativity, showing that nothing with mass can ever exceed the speed of light. Why is light so fast? Because photons have no mass. Everything around us, including you and me, has mass. That means we, now and forever, can never reach the speed of light. In 1977, humans launched Voyager 1, and after 42 years, it's just reached the edge of our solar system. It's the farthest human-made object ever sent into space. Years from now, once it leaves the solar system entirely, without energy from the sun, we'll lose contact, and it will drift forever in the darkness of space. How big is the Milky Way? Light takes 100,000 years to cross it once. Even at light speed, it would take about 5,000 generations to travel across. And that's assuming we can travel at light speed, which we can't. Beyond the Milky Way, there are galaxy clusters, superclusters, and the vast cosmic web. Thanks to the Hubble telescope, we know the observable universe is about 160 billion light-years across, and still expanding. When light-speed travel remains impossible, our last hope might be time and space travel itself. In 1916, physicists proposed the concept of wormholes, tunnels connecting two different points in space-time. If we could use them, we might instantly jump millions of light-years away. Sadly, wormholes are still theoretical, with no evidence found yet. The universe is immense. Earth is but a tiny speck, and it's likely, beyond our universe, there are countless others. Since the Big Bang, the universe has had no beginning or end. It just keeps expanding endlessly. Life may be small, but its existence is meaningful. From our ancestors 200,000 years ago to today's rapid technological growth, we've risen through intelligence to the top of Earth's life chain. But faced with cosmic laws, we can only obey, not defy them. Our average lifespan is around 79 years. In those years, you've laughed, cried, loved, and hurt, met countless people, and lived a full life. Standing at life's end, looking back on those 79 years, ask yourself, do you have regrets? In your heart, there's someone you love most. Right now, they're probably in your mind. No matter how vast the universe, it brought you together on this earth. Whether they're family or love, believe this, it's love that binds you tightly. Humans may never control the universe, but emotions, they transcend it. Because love is forever. In the depths of the universe, there exists a terrifying cosmic monster, so powerful, it can swallow everything in its path. Even light can't escape its grip. This mind-bending force of nature shattered everything we thought we knew about physics. It's called the black hole. But how did we discover such a thing? Back in 1783, British scientist John Michell had a revolutionary idea. He suggested that if a star were massive enough, its gravity could be so strong that even light particles couldn't escape. He called such objects dark stars, what we now call black holes. But his theory was too ahead of its time, and it was ignored for over a century. Then in 1915, Einstein published his general theory of relativity, and German astronomer Karl Schwarzschild used it to calculate something incredible. If a giant star collapses under its own gravity, it could shrink into a point so dense that space and time around it would curve infinitely. Even light would be trapped, crossing a point of no return called the event horizon. So how could we prove this terrifying object is real? Einstein believed that when two black holes collide, they create ripples in space-time called gravitational waves. And in 2015, scientists finally detected these waves, a signal from a collision that happened over 1 billion light-years away. Two black holes, 29 and 36 times the mass of our sun, merged to form a new one, releasing energy equivalent to 3 suns, all in the form of gravitational waves. Those waves traveled across the universe, through stars and galaxies, for 1 billion years, until they finally reached Earth. And in 2019, we saw the unseeable. Using 8 telescopes across the globe, scientists captured the first real image of a black hole, a glowing ring of fire, surrounding the darkest abyss in the universe. But this is just the beginning. Some believe that inside a black hole, there could be a hidden, sealed-off world, or even the gateway to another universe. Only by continuing to explore will we one day unlock the ultimate secrets of the cosmos. If you're fascinated by the universe, don't forget to like, subscribe, and hit the bell. See you in the next video. White heavy checkmark version française adapté à YouTube. Dans les profondeurs de l'univers. Il existe un monstre cosmique terrifiant. Si puissant qu'il peut tout engloutir. Même la lumière inni peut y échapper. Cette force sidérante. A bouleverse tout ce que nous pensions savoir sur la physique. On l'appelle le trou noir. Mais comment a-t-on découvert un tel objet? In 1783, le scientifique britannique John Michell propose une idée révolutionnaire. Si un étoile est suffisamment massif, sa gravité pourrait être si forte K meme les particules de lumière ini pourraient s'échapper. Il appelle cela un étoile noire. C que nous appelons aujourd'hui un trou noir. Mais à l'époque, sa theorie était bien trop en avance. ETL fut oubli pendant plus d'un siècle. In 1915, Einstein publia la relativité générale. ETL astronome allemand Karl Schwarzschild. En deduit un étoile massif. En s'effondrant sous sa propre gravité. Put créer une region OLE space-temps se courbe à l'infini. Meme la lumière sy retrouve PG. À l'intérieur d'une frontière appelée horizon de événements. Alors, comment prouver que ces objets existent vraiment? Einstein pensait que lorsque deux trous noirs entrent en collision, ils provoquent des ondulations dans l'espace-temps. Les ondes gravitationnelles. Et in 2015, les scientifiques en ont détecté pour la première fois un signal venu d'une collision survenue à plus d'un milliard d'années-lumière. Deux trous noirs. 29 et 36 fois plus massifs que notre Soleil. Fusionnant, libérant l'équivalent de 3 soleils en énergie. Sous forme d'ondes gravitationnelles. Ces ondes ont traversé l'univers. Étoiles, galaxies, constellations. Pendant un milliard d'années. Jusqu'à atteindre la Terre. Et in 2019. Nous avons vu l'invisible. Grâce à 8 télescopes repartis dans le monde entier. Les scientifiques ont capturé la toute première image d'un trou noir. Un anneau de feu entourant l'abîme le plus noir de l'univers. Mais ce n'est que le début. Certains pensent occur du trou noir. Pourrait se cacher un monde totalement ferme. Ou même un port vers un autre univers. Seule l'exploration nous permettra, un jour, de percer les ultimes secrets du cosmos. Si vous aimez explorer l'univers, n'oubliez pas de liker, de vous abonner et d'activer la cloche belle. À très vite pour un nouvel aventure cosmique.